Alright, let's go again. The tests still fail, so it's time to implement the neighbors function. I actually found a typo in the next to last test case of the neighbors test. This little bugger. We look at this cell and we expect it to have 2 neighbors, but the test case it actually has 3 neighbors. So I'm just gonna change this one. So we have 2 neighbors, one above and one below. Okay, we can't just return 0 all the time. Okay, the output says number of neighbors is incorrect, got 0, wanted 2. And that is our second test case, I believe. Yeah, this one. I think I have figured this out in my head. I hope that's the case, so it doesn't become another 1-hour video. Sorry about that one. First of all, we look at we need to set some. We are going to loop over the rows and columns of the world, more precisely the rows and columns that are next to, like, right before and right after the position that we're looking at. So we need to establish those limits. First a lower row limit, let's call it low row, and set that to x is our row number, so and we need to check the row above the position that we're looking at, so let's set that to x minus 1. However, if we are on the first row, we can't look at row. If we are on the first row, that's row 0, and we can't look at row minus 1, because that will result in a runtime error of some sort. Index out of bounds. It's probably not called that in Go, but something like that. So if x equals 0, if we are looking at the first row, then we set low row to 0, because we still have to check the same row, because there are, I'm going to show you in the test data here. If we say we are looking at this, we're looking at this, counting the neighbors of this cell, we still have to look at this row, because that one and that one could have neighbors. So that's that. Now we need a high row, and set that to x plus 1. However, it could be that we are on this, let's say we are looking at that cell, we can't examine the row after because there are no more rows. So if x plus 1 equals the length, if x equals, if that is the same as the length of the number of rows in our world, and then we have to subtract 1, because this will give us In this case it will give us 3 because there are 3 rows, but we are interested in the index, and the highest index in this world is 2, since it begins at 0. 0, 1, 2. So that's why I think I'm right about this one. But we'll see if the tests succeed. Anyhow, if this is true, then high row must be set to X. And then we should do the same for the columns. Low col equals y minus 1. However, if y equals 0, then low, I need to change this, low like that, since we went with just hi for high. Local equals y. And this is just, we're looking at the column in this way instead. Like that. And if we are on column 0 like this, we can't look at column minus 1 because there is no such thing. High col equals y plus 1. However, if y equals len, and then we have to look at w. This could, okay, here we have to pick out one row, and actually I don't think Go, if you have a multidimensional slice of slices, slices and arrays are sort of different, and this is a slice, so each row could in theory have a different amount of columns, but in this program we will not make rows of different length, because that would be weird. So we'll play it risky and assume that there is a row here. At least there should at least be one row. I don't know if we have defined, I don't know if it's possible even to create one that has no rows. I don't know. We will take our chances. We use this code, so we will have to use it carefully. High col should in that case be set to, we have to subtract 1 here also, and the compiler, the formatter wants it to look like that. Then we set high col to y. Okay, so now we have our limits established. Now we will loop over these, first by rows and then by inside that by column. So for what should we call that one? Let's call it I. That's equals low row I is less than or equal to, in this case, hi row I plus plus. And inside here let's pick j then, because that's what comes after I. Local j less equal than hi call j plus plus. And here we should declare a variable neighbors equals 0 to begin with. So now if we should not count if we are looking at how many neighbors this cell has, we should not count this cell itself. So we have to make a check that if I does not equal x and j does not equal y, then it should be okay to increment our neighbor's variable. And then we return our neighbors. In my world this should work, but the tests might say otherwise. Okay, which test is this? Got 4, wanted 0. Oh, we have to make another check. We also have to check if this position is true or false. If it is true, that cell is alive and a valid neighbor. So if these two first checks turn out okay, then we can slap on the final check here, and that is that the world at position I, j. This should evaluate to true, and since it's booleans, we don't have to do any equal comparison stuff. Which one is that? That wants 2. It's this one. We got 0. How come? Or is it that one? I should actually add something to the test so I know which test is failing. We can use our index variable here. Case %d, and we will add that here. I case 1, and that's 0. Let's just do it like this. Case number 2, which is this one. Let's just examine the data first. First row, we got 0 and we wanted 2. Let's do some ugly debugging. I know that it should be possible to use a debugger here and step through the code, but I haven't looked into that yet. I will do that at a later point, so we'll just thump some stuff here. Row row percent d I, just to make sure that we actually enter this loop. Missing argument. Oh. J, like that. And here we could thumbed printf, just so we get some nice line breaks. And here let's add a couple of them. This one passed, and this one, that's the second test case. So we actually loop over this. So then it's probably something wrong with this check itself. We got 0 but wanted 2, so maybe it's just not incremented as it should be. I added one neighbor. Yeah, that's not printed. Okay. Those has to be fulfilled at the same time. Oh. Now there's always some those has to be fulfilled at the same time. Is that okay? Maybe we can do it like this. J equals Y. Da-da-doom. Yeah! Okay, so here we check that I is X and J is Y, and slap the parentheses on just to make sure that these are considered as one unit or whatever, and then we negate that because we don't want this to be true. But at the same time, this fella has to be true, and if so, we can increment the number of neighbors. And now we remove these. Okay, good stuff. Thanks for watching. Subscribe if you want to watch the exciting continuation. The next video will probably be some more test specification. Yeah. Bye.